You know, when you look at a modern aircraft, what you're seeing is a total masterpiece of engineering. But what if I told you the real innovation? The secret sauce isn't just in the plane itself, but in the incredibly advanced tools that actually build it. Today, we're going to pull back the curtain and explore the next-gen manufacturing that makes modern flight even possible.
All right, so here's our flight plan for this explainer. We'll start with the insane level of precision needed for aerospace. Then we'll dive into the huge challenges manufacturers are up against. After that, we'll get to the cool part, the innovative tools that solve these problems. We'll even take a peek inside this high-tech toolbox, and finally, we'll look at the real-world industry-proven results.
You know, every single component in an aircraft, from a tiny little fastener to a massive wing spar, is an absolute engineering marvel. We're talking about materials that have to be unbelievably strong, but also super lightweight, and they have to be machined to tolerances so small you can barely see them. Also, they can withstand just extreme temperatures, pressures, and stresses.
And that right there brings us to the heart of the challenge. See, an aircraft isn't just one thing. It's this incredibly complex puzzle made of thousands of unique parts. And trying to manufacture each one, from the nose all the way to the tail, throws a whole different and incredibly difficult set of problems at you. I mean, really think about it for a second. Engine parts? They have to survive inside a literal inferno while spinning at insane speeds. The structural parts need to have maximum strength with the absolute minimum weight. Landing gear has to absorb the massive impact of landing, day in and day out. And those advanced composites, they're notoriously tricky to machine without totally ruining them. The stakes just couldn't be any higher.
So, how in the world do engineers get around these huge problems? Well, the answer isn't just about building bigger or faster machines. The real genius, the real innovation, happens in the design of the cutting tool itself, right at that tiny point where the tool actually touches the metal.
Okay, so let's open up this toolbox for tomorrow and see what's inside. We're going to take a look at a few specific, really groundbreaking tools that are letting manufacturers build the next generation of aircraft and do it faster, more reliably, and with more precision than ever before.
So let's start with something that seems so simple, but it's absolutely brilliant. A traditional drill has these little guide pads or margins running down its side, and those create a ton of friction and heat. The Go drill, though, it just gets rid of them. It sounds like a tiny change, but by cutting down on friction, the cut is way cooler, which means less wear and a tool that lasts dramatically longer. So simple, so smart.
Okay, next up, a tool that's designed to fight another huge enemy of precision, vibration. At the incredible speeds modern machines run at, even the tiniest bit of chatter can destroy a super expensive part or just snap a tool in half. This thing, the Harvey IT, is engineered specifically to cancel out those destructive vibrations before they can cause any trouble.
And here's how it pulls that off. That twisted, cutting edge isn't just for show. It actually strengthens the corners and makes the cut feel a lot smoother. But the real magic is in those asymmetric flutes. They're spaced unevenly on purpose to break up the rhythm of vibrations that naturally build up. It's kind of like a shock absorber for your cutting tool. And it lets the machine run at unbelievable speeds without any chatter.
All right, here's another classic headache for machinists: drilling a deep hole that's perfectly straight. Over a long distance, it's really easy for a drill to start wandering off center. To stop that, engineers came up with modular drilling systems. The idea is to use a replaceable cutting tip on a super stable steel body.
And what's cool is, it's not a one-size-fits-all solution. For bigger holes, one system uses 4 huge contact points to create this rock-solid base for the drill tip, giving it maximum stability. But for smaller, deeper holes, a different system focuses on getting the metal chips out of the way. Its flutes are polished to be ultra-smooth, basically acting like a water slide to clear out debris so nothing gets jammed up.
Okay, get ready for a bit of jargon, but I promise it's worth it. Trochoidal milling. It sounds super complex, but the idea is actually pretty simple and very clever. Instead of taking one big, heavy cut, the tool takes a lot of smaller, super fast, circular-style cuts, but it uses its entire cutting edge. This means way less stress on the tool, but you can strip away material at an absolutely incredible rate.
Of course, to pull off a cool strategy like that, you need a tool that's actually built for it. And that's where this end mill comes in. It was designed from the ground up for trochoidal milling, with special features like chip splitters and a unique helix angle. All these little details help it handle the high speeds and clear material like a champ, making the whole process incredibly efficient.
So we've talked a lot about making the individual puzzle pieces, but what about putting the whole puzzle together, the final assembly?
That requires a whole other level of precision. A specialized tool like the HyPax is designed for one of the most critical jobs of all, drilling and countersinking the thousands and thousands of fastener holes that hold the entire aircraft together. So let's break this thing down. It's a really smart, three-part system. First, you have a sleeve that makes sure everything is perfectly aligned with the hole. Second, a diamond insert creates a flawless, angled seat, the countersink, for the fastener head to sit in. And finally, a specialized carbide drill does the final drilling. Altogether, they do two jobs in a single pass, and they hit the unbelievably tight tolerances that aerospace assembly demands.
Okay, so all this technology sounds amazing, right? But the big question is, does it actually perform out in the real world under pressure? Well, the proof, as they say, is in the pudding, and it comes directly from the biggest names in aviation. I mean, listen to this. This is a huge deal. When a company like Pratt & Whitney, one of the top jet engine makers on the planet, says that a supplier is helping them solve unique challenges, well, that speaks volumes about how well these manufacturing solutions really perform.
And it's not just them. When Lockheed Martin officially recognizes a tool as a preferred product in their own internal guide for their machinists, wow, that is the ultimate seal of approval. It means that tool has been tested, proven, and is trusted to help build some of the most advanced aircraft in the world.
So what's the big picture here? The real takeaway is that the next great leap forward in aviation, it isn't just happening in design studios or wind tunnels. It's happening right now on the factory floor, all thanks to these incredibly sophisticated tools that are constantly pushing the limits of what we can build. And that just leaves you wondering, right? If this is the kind of technology that's building the amazing aircraft we see today, what in the world will the tools of tomorrow look like? What will they be building? Hypersonic jets? Spacecraft? The innovation, it truly never stops.